Oh, hello, folks. I need to get back to my original, don't I? Sorry about that. It's time for another homework demo video. We are in Unit 3, which is about equations, and we will be introducing equations today. First of all, we need to understand the difference and make sure that we are clear about the difference between an expression and an equation. All equations have equal signs. We solve equations. We also later on will graph equations. Right now we have equations with only one variable, and when we have one variable, we're going to solve. Expressions we often simplify. Equations we solve. So let's get started on equations. Before we started solving equations, let's look at how we might translate real-world words into an equation. So that's the first thing that you're going to need to be able to do. When you read 5 more than, a number is usually where I put in the letter X, is, that's our equal sign. 5 more than a number is 8. So I just translated those words into this equation. 5x, 5 plus x equals 8. Number 2, 2 times a number is 10. So the easiest way to write 2 times a number is simply to write 2x. Again, the word is our equal sign, is the same as 10. So you could have written other things for 2 times, but the simplest, bestest way is the way I've written it here. Remember the word less than. When it says 6 less, you have a tendency to say 6 less like this. But this will get you a wrong answer. 6 less is taking 6 away from something. So it's 6 less than what? 6 less than a number. So I have some number and I'm taking 6 less than that, and it is 24. So again, there's an equation written from the words. Let's try a little bit more. 9 subtracted from the quotient, remember this word, of a number and 3 is 21. Read and write 9 subtracted. So I'm going to take 9 away. Take 9 away from what? From the quotient of a number and 3. Well, a number and 3, there's its quotient, a number and 3. And then they're going to tell me it is 21. And what am I going to do after I write it? I'm going to go back and read again and make sure that it does match. 9 subtracted from a quotient, here's my quotient, of a number and 3 is 21. So I feel like I'm matching here. Let's try number 2. The difference gets written just the way I see it. The difference of 7 and 3 times a number is 10. Pretty straightforward. The difference of 3 times a number, oops, should read it the right way. The difference of 7 and 3 times a number is 10. Okay, we can write equations from words. Let's see if we can do it when we are actually looking at kind of formulas that we have seen in the past. Let's read through this guy first. The area of a triangle, so I want to say maybe A, but I'll underline it for now and put a big A above it. The area of a triangle is my equal sign, or is equal to what? Is equal to 1/2 times, 1/2 times what? Times the base and the height. The base and the height. So I'm going to write this in different ways. We could write 1/2 BH. So if you think about that for a minute, that's the same as BH over 2, taking half of the base times the height. So either one of those would be good answers for this question. How about the circumference? The circumference, let's call, actually I think I'll get another color. Let's do red for the moment. Circumference, I'll call that C, of a circle, is equal to the product, that means to multiply, the product of what? 2 pi and the radius. So what do I need to do? I need to go, well, 2 pi times the radius, because that is the product of 2 pi and the radius. Circumference is 2 pi r. Circumference is 2 times pi times the radius is what they're trying to get you to write. You will see several like this in your homework, and they want you to read and write. And you'll have matches. You'll be able to do matching with it. So just use the words carefully. I think they'll be good. These are some wordy guides that I thought I would get you started on. I'm not going to totally do them for you. These two are the same information, asking you to do different things, but to the same information. Let's just read it. A program on television ran for 30 minutes. So this is a 30-minute show, and the program ran 7 minutes longer than 3 times the length of the commercials. You'll have a choice of which equation represents this problem, but we're going to look at it and try to just write the equation. They tell us that X is the length of the commercial. So let's just think for a moment. A program on television ran 30 minutes. So the whole thing is 30 minutes. Well, I think the whole thing is made up of how long the commercials are and how long the show actually is. So let's read again. The program is 30 minutes, and the program ran 7 minutes longer than 3 times the commercials. So do you see that they're telling us that 30 minutes is 7 minutes plus 3 times however long the commercials were. This is the equation, and I want to point out that you could write that equation in different ways. So let me just say, you can put the equals up on the other side. All I did here is just flip the equals. But I also should point out that since addition is cumulative, you might see it written 3x plus 7 equals 30. All of these are the same thing. In the second question, it gives you the same information, but this time it asks you to use guess and check method to find the number of minutes the commercial actually ran. In other words, they're asking you to look at this equation and see if you can guess and check to find out what fits in for X. I'm not going to do it for you. I recommend you use your calculator, plug in 12.3, see if you get 30. Plug in 3.7, plug in 7.7. That's guessing and checking. You're trying to make the equation come out equal. And I'm going to leave that to you and your calculator. Another one tells us about the Sears Tower, and I'm going to just draw a picture for you. I know you can do this once you get an idea of what's happening. So they're telling us that the Sears Tower itself, here's my little picture of my Sears Tower. They're telling us that it is 1,454 feet tall. Here's my Sears Tower. A-R-S. Let the height of the antenna on the tower be represented by the variable A. So now I have a tower antenna here, and they're telling me let it be A long. We don't know how long it is, but A. Then they're telling us that the total of the building plus the antenna. So aren't they saying that we can add these up? And if we add these up, we will get 1707. So kind of drawn your equation, drawn your picture and written your equation, and I'm going to leave it at that for you to finish up in your homework assignment. These guys seem difficult. If you'll work with me a second, I think you will get some help on them. It's hard when you have to answer always, sometimes, or never. It's important, and you'll see what I mean by this in a second, I think, that you check a 0, that you check 1, and that you check a negative number. And I'm going to show you what I mean by that right here. So we're being asked, is 5 times x equal to 10? Well, my first instinct is to say, well, 5x equals 10 if x is 2. But what if x is 0? Then it won't be equal, right? So I'm going to go with sometimes on this one. Sometimes 5 times x is equal to 10. And that would be when x is 2. Did I try 0, 1, and a negative number? Not in this one because I kind of knew, well, if it's a negative, it's going to give me a negative number. But let's try in the next, let's look at the next one. X divided by 0. I want you to do this on your calculator. And if you do some number, any number in the world, 7 divided by 0, you're going to get an error because we are not allowed to divide by 0, and when we divide by 0, we don't get 0. We get undefined is what they say. We're not allowed to do it. So I would say that you can never divide by 0, and that x divided by 0 is never going to equal 0. Number 3 is a little tricky. Is x times x equal to x? Well, most of the time not. If I put in a 2, 2 times 2 is 4. But here's where 0 and 1 become important. What if I put in a 1? 1 times 1 is 1. Or what if I put in a 0? 0 times 0 is 0. So most of the time, x times x does not equal x, but it does sometimes. And that sometimes is x is 0 or 1. Tricky, aren't they? How about this last one? Is x times x equal to x squared? And I think we actually have a formula or a law that says yes. Anytime you have x times x, you're going to get x squared. And we can try things like 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. So all of those are working out. We might try a negative number. Is negative 3 times negative 3 9? Is it equal to x squared? And the answer to all those is yes. So I think we would say this is always true. You will see these in your homework, so I hope you're taking good notes. That's it on homework 1, unit 3, guys. You are ready to go jam on that assignment. I hope you do well. Please ask questions when you have them. Take care, and we'll see you soon.